Hi everyone, welcome back. Now we are in the third tutorial of chatbot using Python. This is where I left in my previous tutorial. The intention of this presentation is mainly to address some of the questions that you might have had while creating this chatbot. The questions like how the response are being generated, what is the algorithm, what is the logic behind this chatbot. So this presentation, I'm not going to show any coding part. I'm just going to talk on the logic of Chatbot Python library with few examples to understand. So in a chatbot, it is very important to consider what types of response is being generated. There are three types of response in chatbot: static response, dynamic response, and generated response. The simplest way is to have a static response with a list of variables. For every user input, it eventually calculates the list of variables, iterates over the list of variables to find the potential response. So it could be a template that are used with a variable name that are being computed. Dynamic response. So in this approach, it will use a resource, it will use a knowledge base, or it will use a collection of documents to get a list of potential response, and then it will score the by calculating the similarity between those response to choose the appropriate response for an user input. This is particularly appropriate if the chatbot acts mainly like a question answering system. In generated response, you will achieve this generated response by using a deep learning technique, recurrent neural network, to train the model to generate a user response. So if you have a huge corpus of examples, huge corpus of conversation, so then you could use a recurrent neural network to train a generative model so that it will generate the response by itself. So in this presentation, at the end of the presentation, you will have an idea about what type of response that we have generated in this chatbot. So Chatbot Python library works by calculating the similarity between the words. Measuring the similarity between the words, sentence, paragraph, and documents is an important concept in various techniques like information retrieval, document clustering, word sense disambiguation, question answering system, and text summarization, etc. Basically, words can be similar in two ways: lexically and semantically. Words are similar lexically if they have a similar character sequence. Words are similar semantically if they have the same thing or opposite of each other, used in the same way or used in the same context. So text similarity approach is divided into three categories: string based similarity, corpus based similarity, and knowledge based similarity. String based similarity is a measure of similarity between character sequence. Corpus based similarity is a measure of similarity between the corpus. Corpus is a collection of documents. Corpus can also be used as a source for knowledge. Knowledge based similarity measures that are based on identifying the degree of similarity between words using the information derived from semantic networks. One of the example is WordNet. WordNet is a large lexical database of English. WordNet is the most popular semantic network in the area of measuring the similarity between words. Our Chatbot Python library works by using string-based similarity. So let's focus on string-based similarity in this presentation. Maybe I will come up with another tutorial for a corpus-based and knowledge-based similarity. So string-based similarity has two types: character-based and term-based. So these are all the list of distance available in character-based similarity, and these are all the list of distance available in term-based similarity. So I will explain both character-based and term-based by giving two examples on each. Let us start with term-based similarity. Cosine similarity. Cosine similarity is one of the distance available in term-based similarity. To understand, let us consider two example sentences. So these are the two example sentences. Then if you take the individual term, distinct term from these two sentences, you will have a list of words like this. If you take the word count, you will get a matrix like this. Now let a sequence 1 be the A vector and sequence 2 be the B vector. Now the cosine of angle between these two vectors is dot product of vectors divided by vectors magnitude. Dot product of vectors is like 1 into 1 plus 1 into 1 plus 2 into 1 up to 1 into 1. Then the vectors magnitude is like a square root of 1 square plus 2 square plus up and so on. So you will get 7 divided by 8.94, which is 0.78. So the similarity between these two sentences is 78%. For the same sequence of sentence, if you calculate the similarity by using a Jaccard similarity, you will get a 0.66. So Jaccard similarity is also one of the distance in term-based similarity. The formula is A intersection B divided by A union B. So if you take A intersection B, you will get 6, and U union B you will get 9, which is calculated like 6 divided by 9 to get 0.66 as a similarity. So removing the stop words also is the way to calculate this. So you can also do that by removing stop words, which you will get 0.625. In my previous tutorial, if you remember, I would have shown you a threshold concept like 0.70, so which is a low confidence adapter. This is a function available in Chatbot Python library. So for any user input, to pick up the response, it will calculate the similarity and find the list of potential response and score them based on the similarity measure. And I have set it as a 0.70 as my threshold. So based on this threshold, it will pick up the appropriate response. So this is how the response are being generated. So you can also modify this 0.70 to up to the business requirement like 0.90 or 0.80. So whichever is relevant. So you can also modify the threshold. Let us move on to character-based distance. So character-based similarity is a measure of similarity by measuring the distance between the characters. So example is Hamming distance. So it measures the minimum number of substitutions required to change a one string to a target string. So for example, the Hamming distance between Dinesh and Ramesh is 3. Like for a term Dinesh to become a Ramesh, 3 substitutions are required, which is a distance. Similarly, for John to become Jack is 3. So if not only substitution but also insertion or deletions are expected in a different length of strings, then the Levenshtein distance is appropriate. So Chatbot Python library by default uses Levenshtein distance to calculate the similarity between the conversations. For example, Levenshtein distance between artist and artificial is 6, which is computed like this. So number of substitution plus number of deletion plus number of insertion. So by default, our chatbot uses this Levenshtein text similarity distance to generate our response. So I thought to address these questions in the third part of the tutorial. So that's it for this presentation. I hope it would have answered the questions that you might have had while creating the chatbot. Thank you. See you next time.